guys some basic concepts of chemistry, you have learned that there are different ways. How do we find the concentration of anything, right? How do we find the concentration of anything? Similarly here, how much gram of this organic compound or that organic compound is obtained, or how much it should have been if I am taking this much moles of X to produce this much moles of Z. So for all those calculations we have different methods. Okay, we have like K-Gildas methods, okay, to find the nitrogen in any compound. Also we have methods for oxygen in any compound. So that we're gonna learn here in the qualitative analysis. So students, now we're gonna learn the qualitative analysis of the organic compounds. So what we will learn here, we'll see that the organic compounds which have different elements, okay, how do we calculate their atomic weight or whatever is desired asked in the question. So we'll see that. So the elements which are present in the organic compounds, they are carbon and hydrogen. But in addition to these, we have oxygen, nitrogen, sulfur, and all the halogens, phosphorus, etc., etc. So we'll do identify them all with some tests. So first of all, detection of the carbon and hydrogen. So carbon and hydrogen, these are detected by the heating of the compound with copper 2 oxide, that is Cu2O. Okay, that is Cu2O. And the carbon which is present in the compound, it is oxidized to carbon dioxide. Okay, and this is very, very clear to every one of you that if I pass lime water to carbon dioxide, it turns milky, right? Why? Because of the formation of calcium carbonate. So that is a test. This gives me CaCO3 with 3 here. So this gets precipitated out. And then hydrogen to water, okay, it is tested by copper sulfate, which turns blue. So if I add H2O to this CSO4, this will give me a blue vitriol, okay, copper sulfate dot 5H2O. Now to detect the other elements which are nitrogen, sulfur, oxygen, okay, and other halogens, we perform a test which is known as Lassagn's test, guys. Lassagn's test. So first test for the nitrogen. So your sodium fusion which is extracted, it is boiled with the iron sulfate FeSO4, and then I pass it to the acidified H2SO4, concentrated H2SO4. So what happens? There is a blue color. Appears. So this blue color tell me the presence of nitrogen present there. So first what happens to sodium cyanide, it reacts with the iron sulfate, okay, FeSO4, and after reacting it, what is formed? It forms sodium hexacyanoferrate, and further heating we get more oxidized substances like hexacyanoferrate, ferriferrocyanide, okay, which is blue in color. So this detects that my nitrogen is present. These are the reactions, guys. Then test for sulfur. So again, the sodium extract you have to make, okay, and it is acidified with the acetic acid and lead acetate. So what happens? A black precipitate this time forms. What gets formed? A black precipitate, and that indicates the presence of sulfur. So in Lassagn's test, always I have what? A sodium fusion metal extract. So PBS is formed, that's why it is black in color. And also if you treat it with the sodium nitroprusside, okay, you will get a violet color. You will get a violet color. That also tells me that sulfur is present. Then test for the halogens. Again, the sodium fusion extract which I have, it is acidified with the HNO3, okay, HNO3, and treated with the silver nitrate. So this is what? Nitric acid, it is treated with the silver nitrate. What are the results? A white precipitate, which is soluble in the ammonium hydroxide, and shows the presence of chlorine there. A yellowish precipitate, okay, which is again sparingly soluble in your NH4OH. Ammonium hydroxide is what? Your NH4OH, okay, NH4OH. So that is the test for bromine, the yellowish precipitate. For chlorine, it is a white precipitate. And iodine, a yellow precipitate, but that is insoluble in NH4OH. That is insoluble. So this is your iodine. This is the difference, that it is insoluble in the ammonium hydroxide. Bromine was sparingly soluble, and your chlorine was very fast soluble. These are the reactions where X represent your any of these halogen atoms, Cl, Br or I. Test for the phosphorus. Now the compound which I have, I heat it with the sodium peroxide, okay, Na2O2. So what happens? It gets oxidized to phosphate. If it is having a phosphorus compound, it will be oxidized to the phosphate. And when I boil this solution with HNO3, then what happens? Then you get a yellow color. So that color, yellow color, the precipitate which is formed, this tells me that my phosphorus is present. Okay, these are the reactions. Na3PO4 plus HNO3, this gives me H3PO4 plus NaNO3. And then this H3PO4, it combines with NH4 whole twice MOO4 plus HNO3. This is yellow in color. Then carbon and hydrogen. So a known mass of carbon compound, okay, if it is burned in the excess of oxygen, I'll be getting what? I'll be getting carbon dioxide and water. Yeah, I'll be getting carbon dioxide and water. And this is the general reaction. This is a general reaction for combustion of any hydrocarbon. Combustion of any hydrocarbon. This is what CXHY plus X plus Y by 4 times of O2. That gives me X times CO2 plus Y by 2 times of H2O. What you will observe actually, the mass of the water which is formed here, it is determined by passing a mixture which is having a weighted U tube and contains calcium chloride. That contains what? Calcium chloride, CaCl2. So with respect of that, I can tell that okay, how much my H2O is getting produced. Also, carbon dioxide, it is absorbed in another U tube, which is what? Which is containing KOH. So KOH is a absorber of carbon dioxide. Okay, so the quantity which it will be absorbing, that you will get to know by the eudiometry analysis, guys. You must have studied in some basic concept of chemistry eudiometry, yeah, the gas analysis. So with that technique, we try to find out the amount of carbon and hydrogen present. And this is the whole setup for this. You can see here there is KOH, okay, at the last KOH you have in this U tube, and in this U tube you have magnesium perchlorate. Also you can have calcium chloride also here. You can have CaCl2 also here. So this is what happens when I heat any organic compound, any hydrocarbon. Next is So what happens, whatever is the increase in your CaCl2 and your KOH, that gives you the amount of water and the carbon dioxide, as discussed earlier. The next test is of nitrogen. Now there are two tests. One is do mass test. What do we do here? The nitrogen containing compound, okay, if I heat it in the presence of copper oxide in an atmosphere of carbon dioxide, it will yield me free nitrogen in addition to carbon dioxide and water. It will give me nitrogen gas. And the reaction is like this. Suppose any hydrocarbon which contains nitrogen, okay, like this, when it reacts with CuO, it gives me CO2, H2O and N2. So we now detect this N2 by the method of displacement of water. So you can see here I have a water not KOH solution, and I am detecting that how much nitrogen is getting produced, and then according to the mole concept I can calculate that, okay, this was the weight of my organic compound which contains the nitrogen, Next method is K-Jaldal method, also known as Jaldal method sometimes, okay, but it is, you may say K-Jaldal or Jaldal, it is the same thing. So it is also for the nitrogen containing compounds, okay. What actually is happening, it is heated with the sulfuric acid, concentrated sulfuric acid. So it converted into ammonium sulfate, the nitrogen, and the liberated ammonia gas, it is absorbed in the excess of standard solution of sulfuric acid. So if you pass the sulfuric acid, it will get absorbed in it, and then we can detect it by doing the titration experiment. Okay, titration experiment by using various indicators, we can find out that what is my equivalent point, okay, what is my equivalent point that has been achieved, and now I can say that, okay, this was my mass of the nitrogen compound which I was having. This is a reaction which goes on, and these are the apparatus, K-Jaldal apparatus. But what is the drawback of this method? The drawback of this method is that it is not applicable to those compound, okay, of nitrogen which contains your nitro and azo group, means if you have NO2 there, okay, and azo group, 2 rings attached like that, so for that this is not very valid. Also, if nitrogen present in a ring like in pyridine, so for that compound it is not valid, because the nitrogen of that will never change into the ammonium sulfate, okay, That's why this is the drawback, that I can have only those compounds, I can detect only those nitrogen compounds which have their nitrogen getting changed into the ammonium sulfate. Then for the halogens, we have Carius method, guys. What do? We take a known mass of any organic compound, we heat it in the HNO3, fuming HNO3, nitric acid, in the presence of AgNO3, as given in the diagram. You can see AgNO3 plus HNO3. Yeah, we take and we heat it up, and what happens? This gives me carbon and the hydrogen which is present, they get converted to carbon dioxide and water, and the halogen which is left behind, it reacts with the silver and it gives me AgI, AgX, okay, anything, AgI, AgBr, AgCl, and it is filtered out and dried, and then we measure it, that how much weight it has. So that is how we proceed for the Carius method. For sulfur, again, we take a known mass of a compound in a heated Carius tube, okay, with Na2O2, and fuming HNO3. So your sulfur compound, it gets converted into the sulfuric acid, okay, and it is precipitated as barium sulfate by adding, if I add more of barium chloride to it, then it will give me barium sulfate. So that can be detected very easily. That can be detected very easily, and it can be then washed out, dried out, and we can measure it. Then comes phosphorus. So phosphorus also, we take that organic compound, we heat it in the fuming HNO3, okay, and it converted into the phosphoric acid. Phosphoric acid. For oxygen, a definite mass of any organic compound is taken, okay, and it is decomposed by heating in the presence of nitrogen gas. So what happens? The mixture of the gaseous product which contains the oxygen, it is passed over the red hot coke, the carbon. So it is like a smelting process, guys. It is like a smelting process. So what happens then? All your oxygen, smelting process of metallurgy, right? I am doing an analogy to it. Smelting process of metallurgy chapter. Metallurgy. So what happens? All the oxygen, it gets converted into the carbon monoxide. Carbon monoxide. I'll write here. The analogy is what? This is just like smelting process of metallurgy. Then this mixture is passed through what? The warm iodine pentoxide. Warm iodine pentoxide. What happens with that? If I pass it to the warm iodine pentoxide, then your carbon monoxide which is formed, it gets oxidized to carbon dioxide, which produce iodine. And iodine is the component, okay. If you pass the starch over it, it will turn blue. It will give me a blue-black color. Yeah, that is called a starch test. So in that way, we find out that okay, my oxygen is present, and we then measure the iodine. And after measuring the iodine, you have to apply the equivalent concept or the mole concept to get the weight of oxygen which the organic compound carries. So the percentage of oxygen can be then derived from the amount of CO2 or the iodine produced. Mainly it is derived from the iodine which is getting produced, because that is what at the end we form, right? Also we can relate it with the carbon dioxide preparation. So this is all about the qualitative analysis, students. Qualitative analysis. So you see there are many methods, okay. So the more you will do the numericals on these methods, the more you will get clear of that, okay, what actually we perform to get our component in that organic compound, right? Whether it is a nitrogen, whether it is sulfur, phosphorus, or halogen or oxygen. So this will come with the practice, don't worry, okay? So students, here we all learn about different methods. How do we find the qualitative analysis of any metal, of any atom which is present in the organic compounds. Now with this, our syllabus of general organic chemistry is complete, but it is still not complete till you don't practice the questions. So in the next part, I'll be discussing some of the JEE questions. That is very important to learn to get you more confidence. So stay tuned with me for that.